Welcome back to Quay Does Leetcode. Today I'm doing problem number 143, reorder list. So for this problem, you're given the head of a singly linked list. And so it just has nodes, and this list in the example 1 has nodes 1, 2, 3, and 4. And what you need to do is reorder the list. And the way you're going to reorder the list is, say node 0 was the first node and node n is the last node. So you're going to reorder the list where it's going to be a new list starting with the first node. You're going to take the first node, node 0, and you're going to make that the first node. But then the second node is going to come from the end of the list at node n. Second node is going to come from the end of the list. And then you're going to keep alternating from the front of the list to the end of the list until you run out of nodes. So your first node is going to be the first node in the list, and then your second node is going to be the last node in the list, and then you're going to alternate again. Your third node is going to come from the if I was the first node, it's going to come from I plus 1. So it's the third node is going to be the previous second node. And finally, you're going to take the next node from the back of the list. So n minus 1 is going to be the third node. So that's how it's going to go. You take one node from the front, and then one node from the back, and then one node from the next front, and then one node from the next back. So that's how you're going to reorder the list. And you can't just change the values in the list nodes. You can only change the actual nodes themselves. So you can't just change the node.val. You have to change the whole node and reorder the list. So how would we solve this problem? Well, let's think about how we would solve it if we were asked to do this for an array. So we're given an array, and our array is I, and then this is n, and this is n minus 1, and this is I plus 1. And we're given 1, 2, 3, 4. So how could we solve this problem where we could change this into we could change this into 1, 4, 2, 3. How could we do that? Well, one thing we could do is we want to be getting something from the front of the list and then the back of the list, so we could have 2 pointers. We could have one pointer starting at the front of the list and another pointer starting at the end of the list. And your red pointer would be moving forward, and your blue pointer would be moving backwards. And so in this case, you would be making a new list, and you would take you would take what's at the first pointer, which is 1, and then you would take what's at the end pointer, which is 4, and then you would move them, you would increment them, you would increment the red pointer, and you would decrement the blue pointer. And then you would take what's at the pointers, so then you would take the first, you would take what's at the red pointer, and that's 2, and then you would take what's at the blue pointer, and that's 3. So that's how you would do it, and that would give you the whole list. So that's how you would do it. You would do it with 2 pointers if this was a if this was an array, but it's not an array. It is a linked list, and a linked list you can only move in one direction. But knowing that, the key here is to think, any solution that you can do with 2 pointers, one starting at the front of the list and one starting at the end of the list with an array, you can actually do the same thing with a linked list if you reverse the second half of the list. So if you have this list, and if you take this list and you break it into 2 halves and you change the pointers from the second half of the list and you reverse it, so you make 4 point to 3, and then you make 3 point to none, because you just want to reverse this half, then you can use the same technique where you can have 2 pointers. You can have one pointer that starts here at the first half of the list, and another pointer that goes and starts at the end of the list, but now the pointers are going this way. So you can move this pointer to the left, and you can move this pointer to the right. So what you need to do is find the middle of the list, which is here, and then reverse the second half of the list, and then do your 2-pointer solution. So how can we find the middle of the list? Well, one algorithm for finding the middle of the list is to use a slow pointer and a fast pointer. So another 2-pointer solution. So if you have a slow pointer that moves, and it moves one spot to the right. It starts here, and it moves one spot to the right. And you have a fast pointer that starts in the second position and moves 2 spots to the right. Well, by the time your fast pointer gets to the end of the list, so this is the fast pointer, it moves 2 spots. So this moves, and it's going to move 1, 2, and it's at the end of the list. And then this pointer is going to move 1 spot, and by the time the fast pointer is at the end of the list, the slow pointer is at the end of the first half of the list. This is the slow pointer. So that's the way we would find the half of the list. So now we have found the half of the list. We found the two halves. We found where the we found the starting point for the second half of the list. That's at slow.next. And so now what we can do is we can take this and point this at none. And we can take, and then we can take this next pointer and point it at the previous. And so now we have reversed the list. And if you want to know the algorithm for reversing a linked list, I show that in a previous video, so you can go back and watch that video. But you can do it iteratively. You can, in place, you can switch the pointers. And then we can just, have our set up 2 more pointers and have one start here, one start here, and then we can, we can make this, we can have the first, we can take the first, what's at the first pointer and make that the first thing. Then we can take what's at the end pointer and make that the second thing. And then we can take what's at then we can increment the pointers, decrement the pointers, or move them forward, and then take the next thing and then the next thing. And that's how you would get that answer. So that is essentially the algorithm for solving this question. So let's see it coded up. Okay, so the first thing that we have to do, is we have to find the start of the second half of the list. So to do that, we're going to have a slow pointer, which we start at head, and we're going to have a fast pointer, which we start at head.next. And there's guaranteed to be at least one node according to the constraints of this problem. So you know that head.next is not going to throw a exception. It's at least going to be none. So we're going to do a loop and we're going to stop. We're going to keep looping until we are at a terminating node in the list. So while we're not at none and we're not at the last node, because the last node has a is pointing to none. So while we're not at the end of the list, we're going to keep looping and we're going to move slow by 1 position. So slow is going to equal slow.next, and fast is going to go 2 pointers, 2 positions up. So it's going to go fast.next. Now, once we break out of this, we are going to, our slow pointers next is going to be the start of the second half of the list. So we're going to say second. So what we're going to do now is after we get the second half of the list, the start of the second half of the list, we're going to reverse the second half of the list. And so our second half of our list is going to start at slow.next. And we're going to just reverse it. So in order to reverse a linked list, we're going to keep track of our previous. So our previous is going to be initially none. And we're going to loop while we're not at the end. We're not at the, we're not at null. We're not at none. So we're going to loop while second, and we're going to keep track of, we're going to save a temporary variable for our next pointer. So second.next, we're going to save that as next. And we're going to need that because we're going to need to be able to have a reference to our next. But we're going to need to break that and change our reference to our next to be our previous. So we're going to need to save it somehow. So we got to save it first. And now we're going to change our second.next. We're going to point our next to our previous. And then we're going to update our previous to be our current node. And then we're going to save what our second, what we were on, the number that we were currently on as our previous, and then we're going to move forward one node. So we're going to say second equals next, because it can't be second dot next because we just changed that. So we have to use the version that we saved. So and at the end, our new list, our new reversed list, the head of that is going to be previous. So we're going to have that as previous. So the final thing we're going to do is we're going to build the reordered list. So we have to have the new pointers, and one's going to start at the beginning of the first list, and one is going to start at the beginning of the reversed list. So the beginning of the reversed list is pointing at previous after we break out of that loop. So we're going to say a new second pointer. We're going to override the second pointer. We're going to make a new second pointer and start that at previous, which is going to start it at the end of the reversed list, or at the beginning of the reversed list. And our first half is going to start at our original head. And now, because our one half could be longer than the other half, so the second half is always the shorter half, because of the way that we did our fast and slow pointers. So the second half is always our shorter half. So we're going to loop until we get to the end, until second is none. So while second, basically, while second is not none, we're going to loop. And we're going to, and for this problem, we only change the pointers and we don't need to return anything at the end. We're just reordering the list in place. We see that this says do not return anything, modify the head in place. So now we're going to make the, we're going to need to save our our next pointers, because we're going to be updating our next pointers with the new order of the list. So because we're going to be updating the next pointers, we're going to need to save them first so that we can get to the, we can traverse the list. So we're going to say next one is going to be first.next, and next two is going to be second.next. Okay, so we have saved those pointers. So we've saved those as a temporary variables. So now what we're going to do is we're going to start from the first thing in the list. So the first thing in the list, the next thing after the first thing in the list needs to be the last thing in the list. So first.next needs to be the last thing in the list, and the last thing in the list is going to be second, because second is at the first, second is at the top of the reversed second half of the list. So that means second is at the last number in the original list. So then we're going to say, so now we have the first number in the list and we have the second number in the list. Now we need the third number in the list. So that's going to be second.next. The third number in the list is going to be the number that comes after the first number in the list, in the original list. So it's going to be next one, because it's not going to be first.next because we just changed that. So it's going to be the reference that we saved. So now we have, so now we're just going to, so now we have the first number in the list, the second number in the list, and the third number in the list. And now we just need to keep alternating. So we need to update the next, we need to update the pointers. So first is going to be next one, and second is going to be equal to next two. So we're just going to move the pointers along. And finally, when we get to the end, so remember, we could have a list that is of, it has an odd number of elements, and the first half of the list is going to have the extra element on it. So, and we're only looping until the second shorter one is done. So there might be something left in the first list. So if there is something left in the first list, so if first, we're going to need to set that element, the next of that element, to none. So we're going to say first.next is equal to none. And that will take care of that case. If the last thing in the list was the if it was an odd number and an even number, and the second we were in the second half of the list and that element was the last thing in the list, it's already pointing to none, because when we reverse the second half of the list, we pointed its previous to none. So it's already pointing at none. And that is the code for reordering the list. And we don't need to return anything. It says we don't need to return anything in this. We just modify the head in place. So that's the code. Let's run it. And we are getting correct output. So let's submit. and it was accepted. So that is how you do the problem reorder list. It's a multi-step process, but in the end, it ends up being, so you have to traverse the list, 3 times, but it's still an O of n time solution because you just traverse, it's 3n, so you traverse 1 time, and then 1 time, and then 1 time. But ultimately that's O of n time, and then we're only, for our space, we're using constant space because we just have some pointers. And so that's an O of n time and O of 1 space solution. And thanks for watching, and I'll see you in the next video.